Welcome to this explainer. Okay, so today we are making a massive pivot in how we handle human-AI interaction. Up until now, we've really focused on discrete AI prompting tricks, those clever little ways to coax out better responses while playing around in a safe sandbox. But today we leave the sandbox. We're shifting gears to treat societal problem framing as a strict, verified engineering pipeline. Because if you want to build a capstone solution that actually matters in the real world, your foundation literally has to be flawless.
Okay, let's dive into this agenda. Think of this as the technical architecture for our session. First, the integrated capstone test, followed by the pace refinement loop. Then we'll cover gating our reasoning chain, few-shot modeling, the edge case audit, and finally, the final defense. We're going to transition a vague idea into a deployment-ready capstone proposal.
All right, Section 1, the integrated capstone test. We're moving from practice to reality.
So we're taking those discrete techniques you already know, and we're turning them inward, applying them with far greater rigor. The delta here is absolutely critical. Previously, it was just practice, right? Isolated classroom skills on safe, prepackaged examples. But now, for your integrated test, you are applying these tools synchronously to your own group's real-world capstone problem. From here on out, every single claim has to be traceable, data-backed, and completely defensible.
Moving right along to Section 2, the PACE problem refinement loop. It's time to name a specific solvable lever. And this brilliantly illustrates that refinement, it is never just a single pass. You'll probably recognize this iterative loop from our earlier revision processes. But now, the focus is narrowed strictly to refining your own problem statement. You are feeding the model your community data, evaluating its framing, and cycling it back through until the output perfectly matches reality.
Let's walk through the actual mechanics. First, draft your problem statement using the full PACE framework: problem, action, context, expectations. Submit it, read the output really closely, and evaluate it using our Q1 through Q5 framework. Identify the absolute weakest link, revise it using your verified dataset, and resubmit. You just keep cycling through these steps until it finally crosses the threshold into being truly actionable.
Just look at the stark contrast here. On one side, we have a weak, generic complaint. Our community has a problem with food access. I mean, there's no specific population, no hard data, no lever to pull. On the other side, an engineered strong statement. Census Tract 1311008300 has 0 full-service grocers within 1 mile. It names a precise population, a verifiable metric, and sets up a highly scoped lever, like an AI-supported produce delivery tool. That right there, that is your gold standard.
Which brings us to Section 3, gating the root cause chain. We have to gate every single link.
To gate those links properly, we first have to lock down exactly what we mean. The symptom is just the visible surface effect, the observation. The root cause is the structural driver, and this must be defended by data. Finally, the actionable framing is your solvable lever. Keep this locked in your mind because every single refinement and audit in this pipeline depends entirely on your ability to distinguish between these 3 layers.
Now, what's really interesting about this slide is how we treat the Q1 through Q5 framework. Think of them as strict logic gates or security checkpoints. You've got your symptom, your root cause, and your framing. Absolutely no claim advances to the next link in the chain unless it successfully passes through these gates. An unverified link compounds, so we literally can't afford to let anything slip off.
You have to run all 5 checks at every single gate. Is it accurate? Is it complete? Contextual? Verifiable? Biased? Listen, if you sneak a fabricated root cause past these gates, it inevitably produces a fabricated framing. And a fabricated framing will spectacularly crash and burn during a capstone defense. Guaranteed.
All right, Section 4, few-shot modeling actionable statements. Let's define our standard.
Before you ever let an AI model draft a problem statement for you, you have to build a few-shot set to teach it your rigorous standard. It's a simple 3-step process. Show the model 2 to 3 really strong examples. State the exact pattern they share, specificity, equity awareness, defensibility. Only then do you ask it to draft your own. If you skip this, the model is just going to lazily revert to the generic, often biased phrasing it absorbed from its training data.
So, the crucial point is that what you feed the model becomes the exact pattern it copies. Feed it housing is expensive, and you get garbage back. But feed it a highly specific rent burden rate mapped to a specific LA County census tract. Now the model learns your exact parameters. You absolutely have to demand specificity by demonstrating it first.
Moving into Section 5, the edge case audit.
time to stress test your proposal. Before any draft becomes an official capstone proposal, it has to survive our final testing phase, a grueling stress test. We are treating ethical issues here not just as abstract moral failings, but as critical, fatal system bugs that have to be rooted out during technical validation. You wouldn't deploy broken code in software engineering, and you sure shouldn't deploy a broken, biased problem statement here.
There are 4 specific edge case bugs you need to stress test for. Hallucination, are you checking for fabricated statistics? Bias, are you rooting out stereotypical assumptions that don't reflect your actual community? Context collapse, ensuring you haven't drifted into describing some generic average city. And finally, scope creep, making sure your lever hasn't grown way too massive to actually deliver in a single semester.
Let's move to and see how this builds into Section 6, the final capstone defense, taking it all from problem to project.
A problem well-defined is a project half-designed. It is a classic maxim for a reason. All this heavy lifting you're doing right now, engineering the statement, validating the data, gating your logic, this is the absolute bedrock of a successful capstone. If your framing is weak, the entire project crumbles.
Okay, before you submit, you need to run this pre-flight checklist. Do you have traced claims, a data-defended root cause, a specific population, a properly scoped lever, and most importantly, your team has to provide a written defense explaining exactly why your chosen root cause is the most consequential and data-backed lever to pull.
So, I'll leave you with this ultimate, hard-hitting challenge. Look at the problem you are bringing to the table and ask yourself honestly, is it precise, defensible, and actionable enough to carry the weight of a full semester capstone? If you've rigorously followed this pipeline, the answer is a resounding yes. Thank you so much for joining me for this explainer. Now go validate your data, gate your reasoning, and ask yourself, what lever are you going to pull?